so this one's a little bit different, okay, because we dealt with one that has tangent, we've dealt with one that has a plus or minus, and we've dealt with one that has multiplication, but what does this one have that we didn't deal with yesterday?
Exponent thingy.
The exponent thingy, okay, which is a square, but yes. We didn't have any that had exponents yesterday, but that's okay. Again, we talked about how we're just doing PEMDAS backwards, yes? So if we're doing that backwards, what do we get rid of first? The -1. So how do we do that? We're going to add it. Then what? Or multiplication and division. Then what?
Square root.
Yeah, so then we're all the way up to exponents, yes, and we can just undo an exponent with a root. In this case, we have a squared, so we can take the square root. Now, what do we have to be careful about though when we take the square root of something?
You have to square root the other side.
I have to what?
Square root the other side.
Yeah, so I did have to square root. So technically I square rooted the whole thing, but what's the square root of 1? 1. Okay, so that's why we just have a 1 on top and then we have a square root of 3 on bottom. What's the other thing that we have to be careful about?
What the exponent is to make sure like you get the right root thing.
Okay, there is something about our exponent. Because like, if I take the square root of 4, what do we get? 2, okay. But if I'm thinking about going backwards, okay, 2 squared does give us 4, yeah? Is there anything else squared that gives us 4?
16.
That would be the square root, right? Is -2 squared also 4? Yes. Kind of. But basically, like, if we're going backwards, right, that means that this technically could have been positive or negative. Because if I square this, I still end up with a positive, right? So whenever we take the square root, we have to put a plus or a minus there. And that's just any sign. So normally when we've been doing these, how many answers have we been getting? 2 answers, right? But now that I'm having to look at positives and negatives, how many answers should I be getting? 4. We're going to get 4 answers this time. Are y'all okay with that? Okay. Now, is tangent on our unit circle? No. But what do we know about tangent?
Sine over cosine.
Correct. Our sine and cosine on our unit circle.
Yes.
Yeah. Yes, how can I be? So remember, we want to look at our first quadrant first. Yes? So let's think about our ordered pairs in our first quadrant. Right? The easiest one, hopefully, to remember is when we are halfway in between, okay, which is pi over 4. Remember that they are both square root of 2 over 2. Yes? Now, if I divide those, what are we going to get? So remember, this one's cosine, this one's sine. If I divide those, what do we get? 1, yeah? Is that equal to this? No. So we know it's not going to be the one in the middle. Are we all okay with that? Yes, no baby. Alright. So then my first one, remember my 3 comes first. So I have square root of 3 over 2 comma 1/2, which means that my other one is the opposite. Yes? So that's just me writing down my ordered pairs for my first quadrant. Are we all okay with that? But now notice, where is my square root of 3?
On the bottom.
On the bottom, right? Which one is on the bottom for tangent? Cosine. So that means that we need our cosine to have the square root of 3 with it. Yes? And remember that these go cosine and then sine, right? So which one do we need to use in order for the
degrees.
cosine? Yep. This first one, which is 30 degrees or opposite. Yes, no, wait. Okay, that's our first quadrant. Where else is tangent positive? case, it's actually not positive in our second quadrant. It's actually not positive in our fourth quadrant either. It's positive in our third. So remember that the acronym is A, Smart, Trig, Class. Yes? All of them are positive in my first. Sine is positive in my second, which means that if cosine is negative, and I divide those, right, tangent will also be negative here. But sine and cosine are going to be negative in my third quadrant. So if both of these are negative, what ends up happening? The whole thing is positive, right? Because they reduce and you just get a positive. And then cosine is positive in our fourth. Are we okay with that? Okay. So that means in our third quadrant, okay, we want a reference angle of pi over 6. So what's the angle that has a 6 in it in our third quadrant?
7 pi over 6.
7 pi over 6. Because remember that this is pi, yes? So if we are bigger than pi, my fraction has to be bigger than 1. So I know it has to be 7 over 6 instead of 5 over 6. Those are the positive ones, yes? How many answers did we say we're going to get this time though? 4. So I also need to list the negative ones, which are going to be our second. So what's our angle in our second that has the 6 in it?
5 pi over 6.
That one is 5 pi over 6. And in our fourth?
11 pi over 6.
So this time we get 4 answers because we had to have that plus or minus. Yes, no, maybe. Again, for the most part, this part's pretty easy, right? Just doing the opposite operations to get to here. Most people are okay with this. It's then using the unit circle stuff to figure out this part that takes a little bit of practice. Because the unit circle stuff is kind of our new stuff, so that's why it can take a little bit more time. What questions do we have on that one? Yeah.
So when you find like the first answer, like you found pi over 6, all the other denominators have to be 6.
Now I will say the only difference would be is like, so say I got a negative, like I only had the negative one. I'm still going through the same process. I'm still starting with my first quadrant because I should have those memorized. So I'm still going pi over 6, but if it was just the negative one, well then pi over 6 isn't going to be one of my answers because that only works for the positive one. But I start there because now I know that I still have to have 6's in my other two. Does that make sense? So I always start with my first quadrant, whether it's positive or negative, because then like you were saying, then all my denominators have to match. Which is why I like using radians more than degrees. Like you can use degrees and this would be 30 degrees, right? But then it's much harder to find your other angles because you have to remember like, well 180 plus 30 is 210, and so that's this one, right? Like you should have to do a lot more math than just being like 6's, and those are my answers.
So just once you find one thing with the denominator, it's just
then all of them have to be the same, yeah. Because our reference angles have to have the same denominator. When it's on our unit circle. We're going to look at one in just a second that if for some reason, whatever, we got 5 here, right? 5's not on our unit circle, so then that means that these aren't going to be nice, pretty answers. So it's going to have some weird, funky number there instead. So, speaking of, let's look at one like that. What's going on with this one?
too much stuff.
A lot of stuff, yes.
There's a cotangent on the right side.
There is a cotangent on the right side. There's also a cotangent on the left side, yeah? So what did we talk about yesterday? Was that when I have x's on both sides, what is it helpful to do? Put them all on one side. So what do we want to do?
Cotangent on the right side.
Divide the cotangent.
I would not divide.
No.
Because when we divide, what are we not allowed to have in our denominator?
Fraction.
We can have fractions, but like, what's the bad thing?
0.
Yeah, 0. We can't have 0 on our denominator. And cotangent can technically be 0 at some of our angles, right? And we don't know which ones that it's going to be, so we can't just divide by it because we could technically be dividing by 0.
Divide by cosine squared.
We can't divide by, you don't want to divide by any of your trig functions. because it's the same thing. Dividing by them is bad.
So subtract.
Subtract, yes. I want to subtract it instead to move it all to the same side. And now it's going to equal
0.
0. Okay. I still got a lot of trig functions. So what's the thing that we can do that's kind of like division, but it just like moves it instead? So instead of like dividing it out, we just pull it out. Yeah, we're gonna factor it. So they do both have a cotangent, which we noticed, which means that we want to remove it, right? Which is why we said to divide it. We can't divide it, but we can remove it by factoring it out instead. Yes, no, maybe.
So we can't divide by, so if it's like that, we can't divide by any of
Any of the trig functions. Now, if it's just a number, right, like 3, we can divide by 3 because there's no way that 3 can be 0. But if it's like a cosine, a sine, a tangent, all of those could potentially be 0 somewhere, so then we would be dividing by 0. Okay. But once we have it factored, remember that as long as this is equal to 0, we can now take like our big equation and we're going to break it apart into 2 like mini equations so that we can solve those instead. Right, just like if I had x minus 2 times x plus 3, right? I just take each of those and make their own equation and now we can solve. We did the same thing here. So let's start with our cotangent. Is cotangent on our unit circle? No. But what do we know that cotangent is? It is. And what is the only way that a fraction can be 0? We said that the bottom is not allowed to be 0, right? So the only way that the whole fraction could be 0 is if the top is 0, right? Because 0 divided by any number is still 0. Okay? So that means that we need what to be 0? Cosine. And where on our unit circle is cosine 0?
90 to pi over 2.
Mm-hmm. And? Yeah, okay with that. But we could potentially have more answers this time because that was like our first little equation. Now we have to solve our second little equation. So what do we want to do first here? Add 2, and then
Square root.
what do we have to make sure we add there? Plus or minus. So we get plus or minus the square root of 2. Is the square root of 2 on our unit circle?
Yes.
Is it? Just square root of 2.
No.
No. Square root of 2 over 2 is on our unit circle, but just the square root of 2 is not. Okay? So remember back to like 2 chapters ago. Okay, it's been a little bit. Okay? Remember that we had a special function that was our arc cosine. Yes? Do we remember that? Yeah. And the nice thing about arc cosine is that it's going to undo a cosine. Yes? Because that's what we're trying to do, is get rid of the cosine, because we want to solve for x, right? Normally we do that by looking at our unit circle, okay? But since this is not on our unit circle, I can't do that. But since arc cosine and cosine are inverses of each other, I'm just going to be left with an x. Are we okay with that? So just like I took the square root of both sides to undo the squared, I'm taking the inverse of cosine, which is arc cosine, to get rid of the cosine. Yes, no, wait. And then we can plug that into our calculator. Do we remember which button on our calculator is the cosine inverse? No. Okay. So remember, you click your second button first, and then you just click the trig function that you want. So you click second, and then cosine, and that gives you cosine inverse instead. And then we would have to do square root of 2, and then we'll also do negative square root of 2. And give us? Does anyone type it back in? What does it say? Domain error. This is bad. Can't do it. What is this? If you just type in square root of 2 instead. What is the square root of 2? Yeah, but like, what is it as a decimal? 1.41 stuff, right? But remember, what did we say? What's our amplitude for sine and cosine? 1, right? It only goes up to 1. So is there going to be an angle that gives us something that's bigger than 1? No, which is why it gave us a domain error. It's saying that you can't do this. Which means that we only get our first 2 answers. So that would be our answers instead. Otherwise, if it did give you an answer, so like say this was, whatever, 3/4, right? 3/4 is not on our unit circle, but 3/4 is smaller than 1. We could type that in, and you're going to get like a weird decimal. It's going to be like 1.72, whatever, right? And you would just write that down, and that would be your other answer. Questions, concerns, comments on that? Like I said, the isolating part is not the hard part. Like using the unit circle for our trace, that's kind of the hard part. Right? Which is why we have some time to practice now.